Yes, friends. So we are doing question number 7 in continuation of the same topic. Okay. So now lecture series 29 we are continuing with. So question number 7 we are doing. Now in this case, let me just remind it again. What is given to us? We are given here a man can row upstream. A man can row upstream 10 km per hour and downstream 16 km per hour. This is given to us. Question: a man can row upstream 10 km per hour and downstream 16 km per hour. Find the man's rate in still water and the rate of the current. So now I have written down here to find man's rate in still water and the rate of the current. Right? So what we have done, let speed or rate of the man in still water, as we have always assumed, in still water be x km per hour and the rate of current be y km per hour. Therefore, the downstream rate of the man, effective rate of the man, is x plus y equal to 16. Downstream is 16 and upstream is 10. So x minus y equal to 10. Upstream rate 10 and downstream is x plus y. We have to add the stream's rate or current, rate of the current plus rate of the man together with, because the person is going down, but that means their speeds are added up. These are the two equations. Now with the help of these two equations, we can directly calculate what is the man's rate in still water, right? By using shortcut formula. So using shortcut formula, we have x equal to half of the sum of these two. Why? Because downstream rate plus upstream rate. So downstream rate is 16, upstream rate is 10, sum of them. It will give us 16 plus 10, 26 upon 2 means 13 km per hour. This is the answer. Man's rate in still water is 13 km per hour. And y is equal to, similarly, the shortcut formula, the difference of these two. Downstream rate minus upstream rate. So this is 16 minus 10. This is 16 minus 10 is 6. So 6 upon 2 is equal to 3 km per hour. These are the two answers. Let me now write the answers here. What are the answers here? Let me write down. Hence, speed or rate of the man in still water is equal to 13 km per hour. This is the answer. Second is, and the rate or speed of the current is equal to 3 km per hour. 3 km per hour. So these are the two answers here. Right? This is 13 km per hour. Man's rate in still water and steam's rate is 3 km per hour. These are two answers here. They have to be calculated. Find the man's rate in still water and the rate of the current. These are the two answers. Okay. Now let me take the next question. What is question number 8 say? Let me first read it and then we will solve it. So this is question number 7. Now question number 8. Let me talk about what is given to us. First let me read it and then I will just solve it. Okay, question number 8 says a man swims downstream 30 km and upstream 18 km, taking 3 hours each time. Now it says taking 3 hours each time. That is the point. Okay. 3 hours each time is 30 km per hour per 3 km or 3 hours. He says a man swims downstream 30 km in 3 hours. That is the rate, 30 upon 3, 10 km per hour. This is speed. And upstream 18 km in 3 hours. That means 18 upon 3. That is 6 km per hour. Alright. What is the value of the current? What is the value of the current? Sorry, velocity of the current, not value. What is the velocity of the current? So velocity of the current we have to find out. Same thing. Let me now first write it down. A man can swim 30 kilometers downstream, 30 kilometers downstream in 3 hours. This is the first information. And he can swim upstream, or he can swim how many kilometers? 18 kilometers. Let me write first that. He can swim 18 kilometers upstream in 3 hours. Okay, this is the point we are given here. Okay, a man swims downstream 30 kilometers and upstream 18 kilometers, taking 3 hours each time. What is the velocity of the current? To find here velocity or the rate or speed. To find velocity of the current. Because current here is moving in one direction, so its velocity. Velocity is having direction. Is a vector quantity, not a scalar quantity. Alright, so let me solve it now. Solution. Let the speed of the man in still water be x kilometer per hour, and the speed or rate, in this case velocity or rate or speed, same thing, and the velocity or rate or speed of the current be by kilometer per hour. Therefore, downstream they are added up. Therefore, the speed of the man downstream is x plus by the sum of the two speeds, the speed of the current or velocity of the current plus velocity of the man. That is equal to how much? 30 km in 3 hours. That means 30 upon 3 is equal to 10 km per hour. And x minus y is equal to 18 upon 3 is equal to 6 km per hour. These are the two equations we are given. Now we can find out what is the velocity. So using the shortcut formula, hence using shortcut formula, what is shortcut formula? Just find the value of y, which is half of the difference of the two, downstream speed minus upstream speed. So that is 10 minus 6. That means 4 upon 2 is equal to 2 km per hour. This is the speed of the or velocity of the stream. That only we have to calculate it, or we have to calculate in this case. This is the answer here. So hence velocity of the current or stream, velocity of the stream is equal to 2 km per hour. Alright, this is the answer. Got the point? Is the answer here. Okay, so question number 8. Only the speed or velocity of the current we have to calculate in this case, not velocity of the man. Man's velocity could also be taken out. How? That is 8 by 16. 10 plus 6 upon 2, that means 16 upon 2, 8 km per hour. That is the speed of the man, the velocity of the man in still water. That was if we had to calculate that. But in this case only the velocity of the current is required. What is the velocity of the current? Okay, not velocity of the man. But man's velocity in this case was 8 km per hour. Why? Because addition of the two speeds. Okay, that was, sorry, what is that? 10 plus 6, right? 10 plus 6 upon 2. 10 plus 6 means 16 upon 2, 8. So 8 km per hour was the speed of the man, or the velocity of the man. That was the 8 question completed, but I mean only speed or velocity of the current was asked here, so that's why I have calculated only value of y. Y is velocity of the current. So that was the answer. Now question number 9. Let me talk about question number 9. What is given to us? Let me check it. The question number 9 says, sorry, a man can row 6 km per hour. In still water, means value of x is given. It takes him twice as long to row up as to row down. Okay, the total time is given to us. It says that he takes twice of the time upstream than that of the downstream. The time is given to us. If I take that t seconds or meter, whatever, t hours suppose is taken in case of going downwards, t hours, it will take less time, and upstream when it is coming, then it will take 2 t hours, twice of the t. Okay, so total time taken is 3 t hours. So in this way total time is given to us. Now he says a man can row 6 km per hour in still water. It takes him twice as long to row up as to row down the river. Okay, find the rate of the stream. Rate of the stream we have to find out. Okay, so that is the point given to us. Let us take what is given to us. Okay, a man, let me change the marker. A man, in this case a man can row, it says a man can row 6 km per hour in still water. That means its speed is given. While, okay, second says, and it takes him twice as long to row up as to row down the river. Find the rate of the stream. Okay, while he takes twice of the time to row up as to row down. As to row downstream, this is given to us. Row upstream, this is, let me write here, upstream. As to row downstream. What does it mean? While he takes twice of the time to row upstream as to row downstream. Means downstream, suppose he takes 1 hour, then upstream he will take 2 hours. That is the point. Now what is given to us then? Okay, so to find out, to row down the river, find the rate of the stream. Okay, here to find here the rate of the stream. To find the rate of the stream. Rate of the stream means rate of the current or the speed of the current. Solution, see here. Solution. Let, which is not given to us, let speed or rate of the current be by kilometer per hour, while mains rate in still water is given as x equal to 6 kilometer per hour. Therefore, his downstream speed is equal to 6 plus y. It will be 6 plus y kilometer per hour, and upstream speed is equal to 6 minus y kilometer per hour. This is what we are given. Now what is given to us? That upstream time taken. Suppose the distance is same. They have to travel 1 kilometer. A man swims down, a man can row 6 kilometers per hour in still water. It takes him twice as long to row up as to row down the river. Find the rate of the stream. That's the only given. Now in this case, time taken is twice. Now let me take what is the time taken. Okay, so 6 plus y, which is the downstream speed, into time, so that is equal to twice of the time. Total distance covered will be, or let me take distance is t, or whatever time is twice of that. So let me do it here. Therefore, twice of the time, distance is the same. Here distance is the same. D, total time, if I find out, that will be twice of that. Okay, so total time, if I calculate, time is distance upon speed. Time is equal to, or let me take d is the distance. Let d is the distance traveled. Okay, traveled in one way. That means d upon downstream speed is 6 plus y is equal to, now this is the time. Here time taken is twice of the time taken is equal to 2 into, or we can say this is d into t. Now this time taken is equal to, let me take here t, equal to t of twice of this. This is twice of d upon 6 minus y. This try to understand. Why this is twice of this? Because this is the time. D upon speed. Distance upon speed. Distance upon speed. But this time, this time is equal to how much? Now I'm sorry, doing it wrongly, because whatever time taken is equal to 1 upon 2 of this, because this is a smaller one, this is smaller one, twice of this will be whatever time taken by this, twice of that equal to this. Now this is okay, but we could do 1.2 here, right? Because this is equal to the time taken, suppose t, then it will take twice t. So dd cancel out. So if I take dd here cancel out, or if I take let 1.6 plus y equal to taken time as t. Therefore this will take twice of this because this is greater, and 1 upon 6 minus y equal to twice t. Okay, so now if I find the value of t, suppose the value of t if I have to put here, then it will be 1 upon t here. From this t is equal to this value. So this is 1.2 value of t from second equation. If I put in the first one, the value of t is 1.26 minus 1.6 minus y. This is okay. So now t cancelled out. This is what I have done there. This is twice of this here. Okay, so now it's okay. So cross multiplying, this is 2 into 6 minus y is equal to 6 plus y. Cross multiplying. Okay. So anyway, whatever time taken in case of swimming downstream, this time is twice of the time taken by going upstream. So going upstream is twice of t, 2t. Okay, so putting the value of t here, this is given. Let me now solve it. This is 12 minus 2y equal to 6 plus y. So 3y equal to 6 and y equal to 2. So from this solving this equation we get here 12 minus 6 equal to 3y because y plus 2y. So 6 equal to 3y, imply that y is equal to 2. 6 upon 2, 6 upon 3 sorry. 6 upon 3 means 2 km per hour. This is the speed. Okay. This is the speed of the man. Now we can just find out that suppose this 2 is there and distance is any distance, suppose 1 km there. What time will be taken by this? So 6 plus 2 is 8. 1 upon 8, suppose hours has been taken by going downwards. 1 upon 8 hours. 1 upon 8 hours, suppose 1 kilometer is distance. And if I subtract 6 by 2, 6 minus 2, 4. 1 upon 4 time taken in case of going upstream. But d upon 6 minus by 6 minus 2, that means 4. So 1 upon 2, this time taken is half of twice of that, because this is 1.4 and that was 1.8. 1.8 hours taken in case of going downstream. Going upstream 1.4 hours, double of that. Okay, because 1.4 is greater than 1.8, twice of that. Let us, the same question is solved. So this is the how. So y equal to, therefore, or hence, the speed of the stream down of the stream of current is equal to 2 km per hour. This is the answer. What the point? So speed of this, and this is upstream speed. Now we can find out what is time. Time taken here in case of downstream is this half of the time taken going upstream. That you can prove here. I proved this. So that is simple. So stream, find the rate of the stream. So rate of the stream is 2 km per hour. This is the answer. Question number 9. Finally we have completed. Now let us take next question. Question number 10. Now question number 10. What is that question? Let me first check it and then solve it. First let me clean it. Yes guys, question number 10 and 11, 2 questions are left over. Let me take question number 10 now. Question number 10. What is given to us? First let me check it. Let me read it first. A man can row 6 km per hour in still water when the river is running at 1.2 km per hour. Okay, so reverse speed is also given. It takes 1 hour to row to a place and back. How far is the place? Okay, total hour, 1 hour is given. Okay, so going downwards and coming upwards, the same distance is coming. The distance we will consider. So it takes 1 hour to row to a place and back. How far is the place? Okay, Simple question. What is given? A man can row 6 km in downstream. A man can row 6 km in still water. A man can row 6 km per hour. 6 km per hour in still water. And the rate of the current is 1.2 km. 1.2 km per hour. This is also given to us. Okay, 1.2 km per hour is given to us. It takes 1 hour to row to a place, and okay, that is given to us. Now it takes 1 hour to the man to go downstream and coming upstream from a place from a new place. Now it says from a new place. Okay, running. Okay, still water. When the river is running at 1.2 km per hour, it takes 1 hour to row to a place and back. How far is the place? That we'll find out. So it takes 1 hour to the man to go downstream and coming upstream from a place. Going down. Okay, to go downstream to a place. Let me take to a place and coming upstream from the same place. To find, what we will find out here. To find distance of the place. Find the distance of the place. Solution. Now see here. Solution. Let the distance of the place be. Let the distance of the place be D capital, D kilometer. Then downstream speed of the man is equal to x plus by y, because x is given. So x plus y downstream, we add both the speeds of the man and speed of the current, but both are given. 6 plus 1.2, that means 7.2 km per hour. 7.2 km per hour. This is downstream speed, and his upstream speed is equal to x minus y. That means 6 minus 1.2. That means 4.8. Why? Because 8 and 4.8 km per hour. These are the two downstream and upstream rates. Alright. Now let us find out the distance of the place. Okay, let me solve it here. So solution we are finding out. Distance I have already assumed that D is the distance. Hence total time